Welcome, and thank you for joining us today for our webinar, Accelerating Brake Design with 3D Scanning Technology, that has been created by engineers for engineers. My name is Maria Fortes. I am Business Development Manager at Creaform for the brand Peel.CAD, and I am thrilled to welcome you to today's session, where we will explore how 3D scanning technology is transforming the way racing car brake systems are engineered. Please note that this webinar will be recorded, and at the end of this session, we will have a dedicated question and answer round. So we encourage you to write down any questions you may have during the presentation. We will be happy to address them and provide detailed answers. Before we dive into today's content, I would like to introduce you to our presenters who will be guiding us through the session. Nick Stevens from NS85 and Joe Winston from MSL. Hello guys.
Hello.
So you can introduce yourselves.
Cool, sure. So my name's Joe Winston. I'm an account manager at Measurement Solutions. The company was founded about 25 years ago, and as you can get from the name, we are mostly focused on measurement. So we started life exclusively working with CMMs, as with calibration, service, software, and support. Around 20 years ago, we became the UK partner for Creaform. Creaform was the first company to make a handheld 3D scanner. And what's very relevant in today's world, the Creaform scanners are all designed and manufactured in China. So with the influx of 3D scanners to the market, having a Chinese design and built scanner is very relevant when we're getting into the worlds of supplying into MOD and people like that. About 5 years ago, Creaform took all of their learnings with this 3D scanning technology and spun out a company called Peel. Now, Peel was focusing on creating a very accessible scanner, both in terms of price, making it a very cheap price point of entry, and also usability, making the scanner as easy and intuitive to use as possible. Today, MSL are a team of about 20 people based in Silverstone and Derby, and we're the exclusive partner for Peel and Creaform in the UK. We have over 600 customers in the UK and look after around 3,000 installations of Peel and Creaform equipment over in the UK. Our customer base spread across a huge variety of sectors from F1, motorsport, automotive, medical, aerospace, 3D printing, heritage, and quite a few others that I can't even think of at the moment. And within all these industries, we've got a range of different applications from metrology, and a lot of our work is metrology based. So our 3D scanners, Creaform's Handy Scan is accurate enough to now start replacing CMMs in some quality control departments. Our color scanners are used to scan objects in full color in places like museums, where they're creating digital libraries of all of their artifacts, also in game studios. So scanners are now used to generate super realistic scenery and objects. So rather than a games designer having to digitally sculpt assets in a game, this can now be 3D scanned to create a very accurate, very detailed model very, very quickly. And reverse engineering applications, which we're going to cover mostly today. A couple of different sort of workflows here, either creating a CAD model of an existing component. So maybe we've got something that we don't have engineering drawings for, and we want to make a full CAD model that we can either manufacture or create drawings for. And also scanning areas to check for collisions and overlap. So maybe we've got a design space that we're working with. We want to be able to scan that area, drop in the part that we're manufacturing, and make sure that it fits where it's supposed to be fitting. And yeah, they're the sort of two workflows that we're going to look at in more detail in this webinar. So I will hand over to Nick, and he will take you through them.
Yeah, thanks very much, Joe. My name is Nick Stevens from NS85. I'll speak to you a little bit more about the company as a background and what we do shortly, as we'll roll straight into the first video of the webinar straight after that. So before I do that, I just wanted to go through a bit of an agenda. We can have the next slide, please, Maria. Just a very quick overview of what we're going to do. So I'm going to go through NS85 and what we do, potentially where the problems were or where the opportunities for improvement were.
Nick, sorry, we hear you not very clear. Maybe you can do something with your microphone. Can you hear him properly, Joe?
Yeah, I've got the same. It's not super clear.
Okay, just give me a moment. Just tell me this now. I've got nothing I can do.
Now everyone can see that the webinar is not pre-recorded. Having some issues, direct issues.
Okay, has that improved things at all?
Yes,
Yeah,
it
that's
is better.
it.
Perfect, thank you.
I picked up on the default laptop speaker instead of my dedicated microphone. Apologies. So yeah, back to the agenda. So I'll run through who we are, what we do, how we use the equipment and the software that we'd like to talk about today. And then we've got three key areas that we're going to run through. One is showing how easy it is to use the equipment on site, as we call it, out of the office if we're at a client to scan some data that we need for a job. The second one is a kind of a complete CAD workflow, or certainly leading into the CAD. We won't touch too much onto the CAD, but that's taking multiple scans in a more sterile environment, taking maybe multiple scans of a component so that you get full data coverage, and then how we can merge that together, align it, and start to create some reference planes and dimensions and the like. And then finally, we look a little bit more at the scan to CAD tools within the software, the Peel.3D software. So that's creating shapes directly from a scan and then comparing our newly created geometry to your original scan data to check for accuracy. And again, we'll quickly show that, pulling that into CAD as well, SolidWorks in our case. Okay, next slide, please, Maria. Okay, so NS85, who are we? We're a small, highly focused engineering team based in the UK, in the Midlands. Most of our work lives in the world of high-performance brakes, lightweight structures, and tricky low-volume projects for motorsport and specialist vehicle manufacturers. A lot of what we do comes down to solving problems where there isn't a clean CAD model, neat drawing, or an off-the-shelf part that actually fits. So we're often dealing with real cars, real components, and real packaging spaces that don't always match what a drawing or any kind of data sheet that we may have been given would say. Quite often they're old cars, they've lived a life, so it's incredibly common that things aren't as expected, shall we say. So that's where 3D scanning has become a really important tool for us. We use it to capture accurate geometry of hubs, uprights, knuckles, mounting faces, interior cockpit spaces, pretty much anything we need to design around or design within. And it gives us a solid, reliable data right at the start of the project, which means fewer surprises later in the process. Once we scan something, that data feeds straight into our design and optimization workflow. Whether we're working on a bespoke motorsport brake kit, reverse engineering an older, no longer available component, or developing a brand new caliper or brake disc for a low volume vehicle manufacturer for limited run vehicles. Having that real world geometry makes the whole process faster and far more accurate. So in summary, scanning helps us work with confidence. It reduces guesswork, speeds up development, and makes sure the parts that we design actually fit first time, especially in the kind of tight packaging environments we deal with every day. A lot of what we do, we're looking for maximum efficiency. We work a lot with topology optimization. So in order to do that, we tend to use all of the space that we can to create our envelopes that we generate parts from. So having the accuracy of the surrounding components or surrounding envelope is really powerful for us. So with that in mind, we'll start firstly, as I said, by having a look at how we use it in our everyday lives on site with the customer. There's just a short video just showing quick calibration of the equipment, and then, like I say, just a bit of a demo showing how we use the software and how easy it is to use. Once the video loads in, it's a bit of a high file size, so it's been taking a little while. Here we go. So firstly, we'll have a look at the calibration of the scanner. We wanted to include this just to show how quick and easy it is. We always do it. Whenever we get the scanner out of the box, we'll calibrate it because it's so quick and easy. It would be mad not to be honest. Whether you need to do it every time or not, that's something maybe Joe can speak on. But to be honest, we just do it for peace of mind because it is so quick and easy. So in terms of equipment that you need on site, it's pretty much 2 plug sockets, and depending on how good the battery is on your laptop, and you're away. So this is a typical application for us, where we're taking a vehicle that a customer has asked us to investigate a high performance brake kit for. So there are certain things that we know we are looking for. We're looking for accurate data that we know we need to use later. But the beauty of 3D scanning is that we can kind of capture a much bigger area than maybe if we were going to do it manually with manual tools and just take those dimensions that we know that we need. And it's already proven on numerous occasions that we'll go back to the scan to look for something. Did we capture that area of a wheel arch or a brake hose bracket or something that we kind of want to ensure is going to fit or not cause a problem when we fit our parts? And as you can see, we start to build up a bit of a picture. So the brake caliper in this instance, we're not interested in. We're looking at the interface to the vehicle, predominantly the knuckle and hub. But as you can see, we captured some surrounding geometry there as well, should we need to do it. There's a bit of a balancing act to be had in terms of what you need and what file sizes you end up generating. And yeah, so this is us in the software, as you can see, very quickly isolating the areas that we need, that we know that we want. A few clicks. There's a little bit of noise left over, relatively common. Just wanted to show here how easy it is to remove that noise. So we've just disconnected those elements from that main manifold that we want to keep, and then we can just select that part and ask the software to keep it, removing everything else. You also have the little bits of noise around the place. Typically, we're not trying to create a watertight model here. We know what we're after in terms of reference geometry, so we just need to make sure that those areas are clean and tidy. So once we've done that, we can go to the next stage of the workflow, which is to create the entities that we know we're going to need, reference planes, cylinders, whatever it might be. So you probably won't be surprised to see that one of the main areas that we're interested in, there's 2 main areas, and that's basically where the disc mounts, which is this reference plane here. We'll double check the standard deviation to make sure that we've got a decent fit to the surface that's been scanned. And then we'll create another plane where the brake caliper mounts to the vehicle. Now we'll force that to be perpendicular to the hub, and that's because we're not trying to measure the actual car. What we're actually trying to do is capture the original design intent of the vehicle. What we can do is force it to be perpendicular, and then we can have a look at the deviation of that from the scan surface, and usually we'll find that the numbers are very small, so it's just a nice sanity check. And then finally, we're going to create a cylinder on the location spigot for the disc, or it's not actually the location spigot for the disc, but the that cylinder that you can see. And that'll give us the vehicle axis center line for that front axle. So that concludes the first video. There are other steps that you might ordinarily do. The first video was more about showing you how easy it is to capture data on site, take some quick reference geometry, and just handle that CAD, the scan data initially. What we're going to look at next goes a little bit further in terms of detail. So we're not going to show you the capture of this component, but this is a rear upright from a Porsche 911 if you're interested. And what we're going to show is aligning multiple scans because we wanted more information than just the front face or just the kind of limited areas. We're going to clean and optimize that mesh more for engineering use. We're not going to kind of do any FEA work on that part. We're not going to create any solid geometry on this particular component, but it's more of a complete model. We might want to do some marketing with it. We might want to do a nice render of it. It just gives us a more complete piece of information to be working with. And that, yeah, forms the foundation for our system development. Okay, if we can have a video, please, Maria. Thank you. Okay, so you can see the component as scanned, and the first thing that we'll do, it will always show us where it thinks the floor is, and again, if it's in an office environment, it's normally pretty good, and then we can just delete everything that initially we don't want. Now what you will see here is there's a couple of areas that weren't connected that we know we might want, and we can just hold control and select multiple entities basically, or multiple groups of elements. So again, you will see some noise. It's always a balancing act, and again, you use judgment and experience whether you kind of rescan or change the lighting settings, have a look at the scanner settings. Typically, we find the software so easy to clean up the areas if you do get a little bit of noise. We typically work with the scan as it comes, even if we haven't done the best in terms of the setup. So here are two scans, the front and the back, and literally as quick as you just saw it, that's aligned those scans. So we've now got a complete body. It'll take a short amount of time to process. But that's now one complete scan. And you can see there's quite a lot of overlapping faces. With experience, you just get a good feel for how well it has merged. It's not always perfect, and hence the auto merge is an option, but there are manual interventions. You can align them by targets, for example. It's very rare that we need to do that, but when we have needed to do it, it's been the answer. So once again, you'll see that we are going to create some reference geometry. That's just highlighting the Scan-to-CAD module. The workflow is very intuitive, from the data cleaning going through into the Scan-to-CAD capabilities. So again, similar to before in terms of the information that we're going to be interested in, we always know when we're scanning the part what we want from it, almost always. So we scan with that in mind. So we'll generate very similar surfaces. In this example, we're going to show this upright being used as essentially a check fixture or an assembly check for interference detection with a brake caliper that's been designed to work with it. So knowing what we're going to use this part for beforehand, we can create reference planes and cylinders based on how we know we're going to mate our caliper to it. Again, force and perpendicularity. And there's two reasons that we did this actually. One was genuinely for interference detection, and also it's not always interference, but sometimes there's a line of sight that you haven't noticed to access a mounting bolt or a bleed screw or whatever it might be, and that's why it's quite useful to be able to go back to the original scan if it was a full vehicle or a full corner, because you get that insight that you might not ordinarily have got without actually fitting test parts to the vehicle. So again, just showing how quick we use SolidWorks. Literally a couple of clicks, you can export into SolidWorks whatever it is you think you need independently or all together. And then we just wanted to show, as with many things, there's multiple different ways to achieve the same thing, but we did just want to show that, you know, creating sketches and planes and, you know, those reference planes that are created in the Peel.CAD software genuinely do come through as just normal reference planes in the CAD, and you can use them as you would use any normal plane. So yeah, it was sped up a little, but that just very quickly showed how we use the model once we've created a decent file. So the next clip walks through an alternative scenario, which is effectively reverse engineering. And it might not be in our particular instance to replicate an exact part, but it might be that we see a benefit from having a reverse engineered model, or maybe a 90% of the detail complete model, if we're going to design a part to either replace it or be very, very similar to it with a particular unique requirement. So not for this exact component, but if there was a similar component, what we might want to reverse engineer the model for is to do some FEA work on it. So to put a known load case into that part, which means when we then develop our own component that's going to be going to the same vehicle to do effectively the same thing, we can just make sure that we're not any worse off than the original design intent. So you'll see us create key entities, add profiles, and use simple revolve and extrude options to form that disk. It's super efficient, super quick, and it pulls straight into SolidWorks as before, where you can just continue modeling. And in fact, you can switch backwards and forwards, which we'll show as well. So this process is very similar in terms of creating planes and cylinders. This is, again, at an increased speed because it is effectively what you've already seen. You'll see us align the disk this time, so we'll create a coordinate system so that when we export the part into SolidWorks, we'll have our coordinate system exactly where we would want it or normally put it. And then we're going to start to create these shapes. So we can do that by doing a sketch on a silhouette, effectively like a section that shows the silhouette through that section, and we can sketch onto that. So we'll select a plane. If it isn't an appropriate plane or it doesn't pick up all of the detail that we want, we may create new planes or rotate particular planes. In this instance, it's pretty good. So again, there's multiple ways that you can work with this. We typically generate a rough shape and then just fine tune it slightly, and then we'll put it into the CAD package afterwards, and we'll probably finish off any details afterwards. So anybody that's a CAD user is not going to take a long time to learn to use this tool. As you can see, it's very similar in terms of the tool set that you've got. And again, all we're really doing is manually creating these shapes. They do snap to the green silhouette edges. They are selectable. There are auto sketch tools that we'll show you shortly as well. And we'll just very quickly get a reasonably good fit to that model. And we can check and improve on that later if we need. Another really useful tool that we genuinely do use is the dimensioning tool. What's a key part of that is, or the main reason that we do it, is all of these dimensions pull through into the CAD. So the sketches that get created in the feature tree will be within the CAD software. So we'll generally create dimensions that we know are going to be useful, but we won't necessarily try to make a judgment call at this point in time as to exactly what the design intent was. We are just adding those dimensions for future efforts, but there's nothing stopping us if we wanted to going into these dimensions and actually editing them to be round numbers or whatever it might be, depending on what we wanted to achieve. It's worth pointing out as well that in that sketch, there's a full suite of constraints: parallel, perpendicular, straightness, all of those things that you'd normally expect to see in a CAD sketching tool. And again, the revolve is as per CAD, as a lot of this is, very simple, and very quickly we end up with a shape representing a disc. So now you can see the CAD geometry. We can turn the mesh off, just leaving the revolve behind. So at this point, we know it's not a perfect model, but it's not necessarily what we're trying to achieve, because in this particular instance, we're not trying to make a perfect replica of the part. We're trying to pick up certain dimensions. So the next area we're going to look at are the wheel bolt holes, basically, or the mounting holes. And we're going to do that in a very similar way. We're going to sketch on that front face. But this time we're going to use the software to automatically create the lines by selecting one of those holes. So that's the section. And we can effectively auto sketch. Again, there's lots of settings around that to adjust the resolution or the tolerance when you're selecting lines and edges. So we've selected that one hole that looked like a very good edge. And then we can pop a dimension on there just to make sure that it has created a true circle. There are occasions if that line was maybe disjoint or wasn't great data, it might create a kind of spline or polygon. which wouldn't be ideal. And again, there's ways around that, but we didn't need to do it in this instance. Again, we know at this point that the design intent is equispaced holes. So whilst we might not have made a judgment call on the diameter of the hole itself, we have just done a circular pattern, again, very much akin to a piece of CAD software. So again, we're just going to do an extrude and subtract. We'll just pull that through. It's got a really good dynamic display, actually, showing you the intent of what you're about to do, which is just a nice little sanity check feature. Okay, so as far as this demonstration goes, that's the level of detail that we're going to achieve. We are aware there's features we've missed. So now we can compare that, the CAD that we've created within Peel with the original scan data, and we'll get a heat map of the accuracy of that model or the geometry compared to that original data set that we had. And you can play around with that tolerance depending on how accurate you need or expect to be. And you can see, for example, where the veins haven't been modelled and the vent holes, they're lighting up, but everywhere else, it's a place where we're pretty happy with it. So exporting to SolidWorks, no different actually to the previous example, or certainly no more difficult. And you can just, excuse me, export that whole timeline. What that timeline is basically a feature tree. So you'll see it will launch SolidWorks, and it will create some nice folders and everything that you need. So everything that's been created is now, in essence, a SolidWorks feature. There's no drawbacks, there's no compromises. Those parts, those features are just SolidWorks features. You can then edit those features. This is where we would normally go in, have a look at the design intent of certain things, make judgment calls or make the changes depending on what we need to be doing. As you can see, we just quickly showed you there, dimensioning up some holes, making sure they're on a PCD and dimensioning that PCD as well. So that concludes the third video, which is our third kind of typical use case. So just a quick run through the key takeaways for us at NS85 and the real world advantages that we see. I think the key benefit really in our work case is that when we start, we do start with accurate real world data. That alone removes a huge amount of uncertainty from early design work, and especially on bespoke or modified vehicles where nothing is guaranteed to match what we might have expected. By capturing that geometry up front, we can make design decisions faster and with more confidence. It means fewer surprises and better packaging and a much higher chance of parts fitting correctly first time. Of course, there's always a curveball thrown in at the last minute, but yeah, it increases those chances. So the whole process from scanning to mesh cleanup, bringing data into CAD, for us, it creates a really smooth path into the design stage. And because the information is reliable, we cut down the need for multiple prototypes or rework, which is a big advantage in low volume engineering when there's always a really tight deadline to be hitting. Which is a really good point. Coming back to one of the first points I made is in terms of making that judgment call of how much you're going to scan to start with. If we were going to go and just make some initial measurements like we used to, we would take all the parts that we knew that we needed, but the unknowns were the problem. Whereas if we've got a decent scan of that front corner, all of a sudden the unknown unknowns can become known unknowns, and we can get into that CAD and pick up any kind of additional clash detections that we would have had to prototype some parts, find out when the first bits went on the car, or 3D print and get parts on a car and use a pen to shave a bit off and go back and try and replicate that in CAD. All of that goes away overnight. So yeah, overall, the scanning helps us deliver precise, tailored solutions efficiently and consistently, and it's become a really valuable part of how we approach projects at NS85. And for anything that we are relying on data and we don't have any CAD or drawings, we'd kind of be lost without it now, and any other process would feel, yeah, quite old-fashioned, to be honest. So yeah, that's me done. And I think now we're going to go into a question and answers round. I hope that was enjoyable. Apologies for the microphone issues at the start. But yeah, I'd like to invite any questions, and myself or Joe will be happy to try and help.
Yeah, I will check the chat box. We have a question from Alex. What was the biggest challenge that you faced in your product development processes? I guess it is for Nick.
Of course, it was probably lead times. It's often a challenge to hit a lead time and also maintain the customer's expectation of fitting first time. Now, of course, most of the time in an engineering world, people understand that if there's a lack of data, then there's always a process to go through. But nothing quite sharpens motivation like a deadline. So I think the challenge before was it was literally getting that accurate data. Some of our customers are really close, so it used to be okay to pop down and find out an extra piece of information or trial fit a 3D part, but it would always add time, without a doubt, and usually inconvenience to get a vehicle back on a lift or whatever it might be. So yeah, that was probably the biggest challenge for us, is getting all of the data that we needed at the start of the project, rather than having to make compromises halfway through when we find out new pieces of information or changes in geometry.
Okay. Okay, then let's go to the second question. How did you perform the task before you had a 3D scanner, and how long did it take you?
Okay, that's a good one. Of course, in terms of how long it would take, depends on the project, but typically if we had a brake kit project, let's say, like the first video, we would probably allow for at least half a day on site to take all of those measurements. And it would be with traditional measuring equipment. We would take wheel profiles with like tile cutter templates, for example, and make cardboard templates and kind of trim it to make sure it was accurate to the wheel, which, you know, is actually pretty good, but it's laborious, and it means that we only get one opportunity to do that. Yeah, vernier calipers, parallels, kind of anything that we could do, a host of photos. You can do quite a lot with a photo, putting that into CAD and generating some scale dimensions from it for sure. But just the ability for us to be able to take a more complete picture at the start rather than just those key dimensions is a whole benefit on its own. But in terms of the timing, we would probably be able to achieve all the information we wanted for a brake kit, for one typical example, in maybe an hour and a half instead of 6 to 8 hours. Like I say, there's added benefits that we've probably got more data in that hour and a half as well than we would have had. So
yeah, there is a big difference.
Yeah.
We have another question. What role do tools like Revolve and Extrude play in creating accurate CAD models from scans? I don't know if you can answer that question, or if you prefer you to take over that one.
Take that one.
Might be one for Joe, yeah.
Nick a little break. Yeah, so I guess the original, the first sort of scan to CAD workflow was very much take your scan data, get your STL, drop that into kind of a CAD package and start to sort of sketch around that that mesh. Now we've got the ability to do revolves and extrudes in the Peel software. It just means that we can nicely interact with that scan data and create a true complete cylinder. So rather than a scan data, you might have a little bit of sort of undulation depending on the resolution of the scan data. You might pick up little kind of indents or maybe like rust spots or corrosion, so you wouldn't get a perfectly true cylinder. But being able to create a sketch and then revolve or extrude from that just means that we've got a complete kind of pure true surface rather than relying on scan data that might pick up elements that we don't necessarily want.
Okay, thank you. We have another one from Anne. I guess it will be for you as well. What file formats are supported for exporting into CAD software?
So yeah, export wise, I guess it depends how much of the process you're doing in the Peel software. So if you're purely scanning, taking that scan data out and you take it out as an STL, You might go for what we saw in, I think it was the second video that you showed us, Nick, where you're creating entities. So we might have our scan data and create a cylinder, create some planes, then we can export just those entities into our CAD package. So we can export those out if they're cross sections and sketches. They can be exported out as DXFs or step or ArcGIS files if we're exporting out cylinders and planes. Or we go the next step and actually generate the CAD model in the Peel software itself. Then we can export that CAD solid, again, as an IGIS or a step, or we can export that whole workflow out into SolidWorks and have a completely editable workflow in SolidWorks.
Exactly, with this parametric transfer into SolidWorks. And we have now a very nice one for Nick. What is the biggest benefit that your customers see in your products?
Okay, so you probably won't be surprised to hear the answer to that is the efficiency with which we can carry out projects, really. We're less in their hair, if you like, if it's a project that we need to collect data from on site. And I think the overall confidence that the parts are going to fit first time, it's got to be that. It's got to be the fact that they can set their build timelines of a vehicle with just higher confidence that their suppliers, us in this instance, are going to provide parts within the timeline that we originally thought, because there's just less curveballs, there's less obstacles that are thrown in at us, and if they are, then we've quite often just got to go back to that original CAD data rather than going back on site to kind of analyse the problem. So yeah, I think efficiency and reliability to hit deadlines has got to be the main one.
Okay, thank you. Then we have 3 more questions. Is it possible to import data from other sources into the Peel software? If so, what formats can be imported? Maybe you can answer that question, Joe.
Yep. I guess kind of two different sort of ways that you might want to bring data in, and we kind of saw both in the videos that Nick showed us. It might be that we want to bring in CAD models, so we might want to bring in step files, IGIS files, and use those CAD models to compare against scan data. So if we were doing a kind of an inspection workflow, we might want to scan a part, then overlay that scan data versus the CAD model that it was manufactured from. And we would get a similar heat map to what we saw earlier. So we would see what areas are in spec and out of spec. Import wise as well, the Peel Pro software is sort of fairly hardware agnostic, if you like, where you can bring in mesh files. So in the workflows that we saw here, we were working with scan data from the Peel scanner. And I think we spoke about this the other day, actually, Nick, so you might want to add something here. But Nick, for example, they might have customers that have got their own scan data. So they might scan on a different scanner. They can save those scan data out as STLs, and then they can send them over to Nick. Nick can then open them in the Peel software and use those as space envelopes or fit checks. I think that's kind of generally, is that the way you would work, Nick, with using customer data yourself?
Yeah, and that exact scenario has happened whereby we get approached for a project, and actually they've already captured that data, whether it's in-house or they've had a third-party supplier do that for them. And part of their request for quotation, if you like, is here's all the information. Let us know what the scenario is going to be, and we can pull that straight into CAD and take all of those reference geometries the same as we did before. So yeah, super useful actually.
And I would like to point out that yeah, you can import data from other sources, but only in the Peel.CAD Pro software. I mean, not in the Peel.CAD. So you said in the Peel software in general. So I would like to clarify that.
Okay.
Then we have 2 more. In the first video, you scanned a shiny disc brake. How does the scanner, the Peel 3D scanner, handle reflective or shiny surface? And are there any special techniques or settings required for optimal results? So do you want to answer that one, Nick, or suits Joe? I guess Joe.
I can definitely answer with our real world experience, and then Joe can kind of probably put a little bit more technical background to it. But for us, we find normally the scanner automatically handles the exposure. It can be unpredictable sometimes, and I think that's probably because the differences between the human eye and actually what the scanner's seeing. So what you think, the setting that you think you're going to need isn't always the best setting. But again, with the touchscreen panel on the back of the scanner, you can change the focus mode or the exposure mode very, very quickly. You might need to go into a dark mode or a light mode and just adjust that. But yeah, for us, the automatic setting works really, really well on a high variety of things, and there are occasions where we need to tweak it, and a few clicks on the back panel seems to figure it out for us. So.
Yeah, I think
professional.
No, I think that's pretty good. I think that covers it all. They mentioned the automatic shutter speed. So the Peel is going to be able to see what it's trying to scan. There's the shutter speed dictates how intense that light is, and we want a more intense light for dark surfaces that are going to absorb that light, and then a less intense light for light surfaces that are going to reflect it. So the automatic shutter speed is the scanner is going to look at the area it's trying to scan. If you're scanning a very small light part on a very dark background, the shutter speed is going to default to that dark setting. So you might not necessarily pick up the part you want to scan, and vice versa, which is why you might want to toggle between light mode and dark mode yourself. In the Peel Pro software, you've got an adjustable slider, so you can really fine tune that shutter speed to be able to pick up the surface, the exact surface that you're looking for. For shiny surfaces and I guess also sort of translucent surfaces, so people scanning entire cars, I might want to pick up windows. We can use things like scanning spray or just tape. So a scanning spray just sort of dulls that reflective surface and stops too much light sort of bouncing around and picking up lots of noise. For entire cars, we've seen guys just using sort of masking tape around the edges of the windows, maybe stick a few targets on that masking tape, and then you're just going to pick up the sort of the outline of the window, and then in the Peel software afterwards you can just fill the hole that's left, and that'll give you a nice kind of complete scan. So yeah, a few sort of tricks and tips involved with scanning reflective surfaces and glass and transparent surfaces as well.
Yeah, but it is possible with the scanning powder. So okay, perfect. And then we have another question from the same person who did the previous one. In the second video, you scanned without asking, without using position and targets. How does the Peel 3D scanner maintain accuracy and tracking in targetless scanning mode? And in which situations is this approach recommended?
Okay, so the Peel scanner is a white light scanner, and it can pick up color and texture. It can also use that color and texture to sort of track itself. So rather than looking for tracking targets, it can use color and texture on a model to sort of track where it is in space. So for very sort of feature-rich and color-rich parts, you don't really need tracking targets at all. It doesn't make the scan any more or less accurate whether you use tracking targets or not. If you're trying to scan something that's not very feature-rich, like I don't know, a table with no real features on it, then it's going to struggle there because it's got no reference between one part and the next section of it. Target-less scanning is really useful for things like I talked earlier about museums that are scanning artifacts to create digital libraries. So you might have something that's very, very fragile and you don't want to touch it, you don't want to move it around, and you certainly don't want to be putting sticky targets on it. So something like that is a very good candidate for target-less scanning. I think that covered all of the questions. I think there was a few questions within that question, but I think that covered all of it.
Okay. Yeah, thank you. At the moment, we don't have any other questions. In case that any attendee has questions later, you can send us an email and we will be happy to get back to you. I wanted to say thank you. Well, to all the attendees for being here today, and also to Nick and Joe for presenting and for sharing your experience with the scanner with us.
Great, thank you, Maria.
You can continue. Okay. So then, we will end this session. If any of the attendees has any questions at a later point, please don't hesitate to contact us. And yeah, I wish you a nice afternoon and a nice day to those that are watching us from the USA. Bye-bye. Take care.
Thank you. Bye-bye.
Cheers. Bye.